you have any questions, stop me. The first thing we say we should do is always look for denominator restrictions. Do this first. Find your domain restrictions. Factor anything, find your domain restrictions. Give me your new domain. Okay, then factor and reduce. You might have to factor to find your domain. Factor and reduce. From there, go to your asymptotes. Your asymptotes, always graph this in your y equal, but don't try to sketch it till you do your asymptotes. Your asymptotes are what's going to help guide your actual graph. Find your asymptotes. You have to know that your vertical asymptote is what's left in the denominator after you factored it. We didn't have anything to factor here. So our vertical asymptote was our denominator. And that just so happened to be the domain restriction. And in your graph, it'll say, at the 0, it'll say error. Okay? Horizontal asymptote, take the highest degree in the numerator, the highest degree in the denominator. If they're the same, then you're going to make a ratio here. So a horizontal asymptote is a line. It needs to say y equals. So this gave us a y equals 1/2. Don't give me 1/2. It's a line that says y equals 1/2. Okay, so God bless you. Once you find your asymptotes, then sketch your graph. It's your guidelines. These guide where your graphs are, where your curves are going. Use your calculator also as a visual, and use your asymptotes to guide you. You had to find the asymptotes, which we did, and find the intercepts. The x-intercepts, this is important. This is why we do these separate. Zeros of the numerator. Okay, zeros of the numerator. I look at my numerator, I set it equal to 0. There's my x-intercept. My y-intercept, set x equal to 0. Go back and take out the x and show me algebraically. 0 minus 1 over 2 times 0. Whoop, I can't divide by 0. So it's undefined. So I have no y-intercept. And clearly, why don't I have a y-intercept for this? Because it can't touch the y-axis, right? Because isn't that where my asymptote is? At x equals 0. So I clearly cannot have a y-intercept. Well, when you walk through these parts, if something doesn't jive with your graph that you drew, then either you did something wrong, or maybe you graphed it wrong, but that's a good indicator when you get your intercepts. Did I do this right? Okay, now some of these I asked for all of them, not to the end, I just asked for different parts of these. So are we okay with this? Okay, this also has an increasing section and an increasing section. Here, does it have a max or min? No, no max or min. Remember, your calculator can't show you, well actually this one has a 1/2, but it tends to do this. It tends to stop, and it tends to do this here, stop. But right along your axes, it looks like it stops, but it doesn't stop. It keeps on going, and you'll know that as soon as you draw your asymptote. Like I said, the color ones are so nice. Also, we're coming to a break for the college kids. When they get off about the 15th of December, 18th, 20th, around there. Go online and go to eBay, probably the end of December, like right after Christmas. They'll be selling their calculators. When kids go to college and their college course says you need a TI-84, you need a graphing calculator, they go out and buy one. Usually they buy it from the store if they don't know any better. And they buy it from the store and they hardly ever use it. I buy all my calculators off of eBay. You can get it at 84 for 40 bucks. Don't spend more than 40 bucks. If you bid and somebody outbids you, drop it at 40 because you'll find it somewhere else. And go for the 84. The 83s you could buy for like 20 bucks, less than 20 bucks. And then it's yours. So when you go to college next year, you have it with you and you don't have to spend $130 for a calculator. But the color ones are really, really nice. Really more expensive, but really nice. Okay, so this guy, same setup, right? First thing we do is check for the domain. We say, okay, I go to my denominator. Well, looks like I can't use a zero. Take it out of my domain. Is there anything I could factor and reduce? Yes. Monique. You're okay? Yeah. Okay. Can I factor and reduce anything? I cannot cross out the x's because they're terms. And I can't factor an x. And they're not perfect squares because of the 3. So I leave it the way it is. And it certainly looked like a strange graph, didn't it? So if you graph this guy on your calculator, we're going to add your asymptote to this one. We're going to graph this and put your asymptote in it. And you'll see how nice this is. So let's graph this guy. Once we find your asymptote, we'll put that in there. Yes. Okay, good. Thank you. I'll check it off. Okay, so we're going to graph this guy. And it looks a little bit strange. When things are kind of slanted, you probably have a slant asymptote. So we'll check. So we have nothing to reduce, so we start with your vertical asymptote. Zeros in your denominator. Okay? Horizontal asymptote. I have 2 over 1. When the degree in the numerator is greater than the degree in the denominator, you do not have a horizontal asymptote. And clearly, doesn't your graph show you that these are not guiding on any horizontal lines, right? We can kind of see that. So even if you forget the rule, use your graph to help you. However, I do have a rule. When the degree in the numerator is exactly 1 more than the denominator, we have a slant asymptote. A slant asymptote, you're going to divide by the zeros in the denominator. Set that equal to 0. So I'm going to divide by 0. I'm going to pull out my coefficients. I do not care about my remainder. And because I'm x2 over x1, this is going to be a linear line. A line. So on the line, y equals 3x. Now, in your calculator, it's very nice to go put this in y2. Y equals 3x. And watch your asymptote go through. See it? Your asymptote is guiding these pieces. This part is based on this asymptote right here, the x equals 0. This end is based off of that asymptote. See it? So it's helpful to put it in. If you're looking for a max and min though, take it back out. Just use it to see if it guided your end behavior, which it did. Okay, x-intercept, well I could tell that I intercepted that graph twice. And if I look at it, it's not exactly where I thought it would be. It's not exactly at the 2. And I could look in my table, and I don't see a 0 here, do I? It kind of passed right through it. I don't see a 0 here. It should have went to 0, but it didn't have a 0, which means these guys are irrational. So zeros of your numerator, set that to 0, divide by 3, take your square root. In pre-calc, guys, we don't have to, you don't have to rationalize your denominator, but you still have to reduce everything. This becomes plus or minus, and separate this. 2 over radical 3. You still have to reduce all radicals, you have to reduce all fractions. If you give me decimals, how many decimal places do I want? 3. From here on in, I'm going to be counting off points if you're not giving me 3. You don't have to rationalize your denominators anymore. That's the nice part. You can leave the radical in the denominator. Your y-intercept, if the x is 0, we're not going to have a y-intercept because clearly our asymptote was there on your y-axis. So it can't cross, ever cross a vertical. It can cross a slant as well as a horizontal, but it can never cross a vertical because that's your denominator. Okay? Stop me if you have questions. This one was a little strange looking also. Okay, find all asymptotes. I threw the y-intercept in there just so that you get a feel for where it's dipping to. The denominator, does this denominator have any restrictions?
No.
In your real numbers? No. If I set this equal to 0, this is a -1. I don't care about imaginary, so I have no restrictions. There's nothing you can put in x and square it and then add 1 that you'll get a 0 therefore.
So when there's no restriction, what then happens?
You have no domain restriction, right? You have no domain restriction, and therefore if there's no restriction there, you're going to have no vertical asymptote either. If I can't do that one either, I'm going to have no vertical. So I do have a horizontal. The numerator is an x squared, the denominator is an x squared, and it's 8 over 1. Y is equal to 8 over 1. When you graph that, put that y equals 8 in there. Use your graph to help you. If this is my graph, here's my 8x squared. Put this in. Like my new calculator? So much better. And here's my y equals 8. I can put a y equals, I can't put an x equals, but I can put a y equals. Watch how this is going to be guided by your line there. Look at it, see it? See your horizontal asymptote? Put it in your graph, that'll help you. That'll also help you get your range. What is the range for this function? I didn't ask it, but what is the range for this function? According to what we have here.
-9.
-9 to where?
No, 8.
8. But it can't use, oops, I wrote infinity. Because you were saying infinity. 8. I am. But we can't use 8, right? We can't use 8 because that's an asymptote.
Oh, I know.
So isn't that range a little strange looking? But that's right where your graph is, isn't it? Your graph is right there. What's your domain on this guy?
-75.
Good. All real numbers. Good. So to do our range, we would have to find that y-intercept, right? So there's a number of things I can ask you for these tomorrow. Do you have this one? These two? I don't think you have this one. Do you have this one?
Yeah,
Okay. So I don't think you have this one.
I have that.
You have this one too?
Yeah.
Oh, okay. All right.
No, it's not that exact problem. Never mind, I'll tell you.
Okay.
Number 11 we have.
Okay. Number 12 you don't.
It looks just like that, though.
It does look like that, and I'll go over that one with you, but I didn't want to give it to you for homework because it's kind of a little bit different when we do this. Okay, so let's take a look at this guy. Can I factor that numerator? Can I get an x minus 1 out of that? How do I know that if I can factor this? 8 times c says what, Gabe? 4 times 7 says what? Says what? Do you have factors of 28 that gives you a difference of 2?
Definitely not 4 times 7.
Definitely not 4 times 7. Any other?
I think it might be.
2 and 14 doesn't have, so we can't factor that, right? So we need to know if it's factorable, so it's not. We have to use the quadratic, but we don't need to do that. I just was wondering, can we reduce this? If it's factorable, we have to reduce it. Can't do it. Okay, so.
The quadratic's that long equation.
Yes, it is. So we pull out your denominator and we find out, and I realize it didn't tell you to find your domain, but we're going to just do it anyway. So you're going to take it out. Okay. Now, It asks for your asymptotes only. Horizontal asymptote. Your horizontal asymptote says your degree in the numerator is greater than your degree in the denominator. So there is none. And clearly, does my graph use a horizontal asymptote to guide this? No, it's kind of slanted, isn't it? When I graph it, it's kind of slanted. So I say, oh yeah, it's a 1 greater, I have a slant. Set the denominator equal to 0. There's where you have to divide by. Go divide by -1, set that equal to 0. Divide, get rid of your remainder. This is an x, so y equals 4x plus 2. Here's your slant asymptote. And I think I browsed over the vertical. Your vertical was what was in your denominator, the x equals 1. Now, sometimes, guys, I can see this. Sometimes I can't see this. So you're going to have to watch this. Let's put this in here. Okay, I'm going to put your slant asymptote in the second one. That's going to help guide your end behaviors. There's my graph. It looks kind of like slanted, so I say, oh, I must need a slant asymptote, but I don't see the other part of it. Something's happening here. Where's my vertical asymptote? At what? X equals 1. So somewhere right here is my vertical asymptote. Now, watch. These are like vertical angles. See where these two things cross? If I have something down here, I have to have something up here. I just can't see it. Why can't I see it? The window. So if I asked you for a min or a max, or an increasing, decreasing, what would you have to do? Change the window. Very good. So let's change the window on this guy. Oh, I don't think it'll let me erase. So let's change your window on this. Let's see where that happens to be. I'm just going to take a guess right now and just change my Y max to 30. See if I see anything. There's my bottom. Ah, there it is. It does exist. See it? It's there. You just can't see it. And here's my x equals 1. Here's my asymptote. There's my x equals 1. So when you only see one part of that, and you have a slant and a horizontal and a vertical asymptote, it's there. Sometimes it happens in the lower section. Sometimes it happens in the upper section.
So how do you know if it's inside the triangle or outside the triangle? You just have to look at the graph, right?
Well, one of the things you could do is just look at your table. You should be able to see like where it falls.
Mm-hmm.
Like when I looked at my graph, say I did my Zoom 6. And I didn't see this anywhere, right? I couldn't see this.
Mm-hmm.
So I say, well, technically, I know something's got to be there. Let me check x equals 2, x equals 3. Let me see where that is. So when x equals 2, look where I am. At 19. I'm pretty high up there. See it?
Mm-hmm.
Keep going down. Look at these. I'm at 19. I'm at 21. I'm way up there. I got to set my window to at least get up there. Make it 30, 40, so you can see that part. This didn't need that, but you might if you're looking for maximums and minimums. Okay. Now I didn't give you 12, right?
No.
Let's do 12 together. Just you work 12 with me here. So I pull this up. I graph this. Let me get rid of this. I graph this guy. Guys, stay with me. This has a little bit of a unique thing. I didn't want to give it to you last night and confuse anybody. But I do want you to be aware that this happens. Okay, I'm just going to zoom 6, standard graph, and I should see my graph. Okay, again, look what your graph does. It doesn't show that it comes from way out there, but it does. It keeps going out there. So I say, okay, I look at my denominator. I can't use a 5. I take the 5 out of my domain. Agree? I factor. I've got a factor of x minus 5. I take it out, and I'm left with this. So this is what I'm left with. X minus 5 is my point of discontinuity, right? Because I factored that point out. So I say when x is 5, I have a point of discontinuity. I take my reduced version, I plug in 5, and I say, whoops, I got 1 over 0. I can't do 1 over 0. So what happened to my point of discontinuity? It doesn't exist, my point of discontinuity. Why? Because that's where my vertical asymptote is. My vertical asymptote is there. My point of discontinuity has no pull over my vertical asymptote. My vertical asymptote rates the heights. Because we can never cross a vertical asymptote, it's in the denominator. So even though I was able to remove this factor, and that could have been my point of discontinuity, but look what happened. They were all the same factor. So I was still left with that being an asymptote. I didn't want to give you last night to confuse you, but just to show you that that can happen. Okay? That it happens. All right. And then I think the last one I gave you. All right. Let's do this one together. This had you do everything. So this had you find the intercepts, the asymptotes, points of discontinuity, the max, the mins, the domain, the range, and the concavities. Thank you. All right. So let's walk through this. Okay, can I factor this numerator? Try. Can I factor the denominator? I have a 2x, I have an x, I have a 3 and a 1. I need that little middle difference to be a 1. So do I want to multiply the 2 by the 3? What does that give me? 6. That's way too high. I'll never get a 1 left over in the middle. Because 1's a plus, 1's a minus. I'm going to put my 3 here and my 1 here. I get a 2, I get a 3. Doesn't that difference give me 1? Okay, where does my negative sign go? Here. So watch my middle terms. Negative 3x, positive 2x. There's my factors. So x plus 1 comes out, and this is my point of discontinuity. So before I take out my point of discontinuity, I'm going to do my domain. So x is equal to 3 halves, and x is equal to negative 1. So my domain says, from negative infinity, jump over to negative 1, go from 1 to 3 halves, jump over to 3 halves, and from 3 halves to, sorry, this is negative 1, from 3 halves to infinity. Good? Okay? Now, when you factor this out, you are left with, make sure you write what you factored out to. You are left with this. This guy became your point of discontinuity. Let's hit your vertical asymptotes. Vertical asymptotes is what's left in your denominator. I'm left with 2x minus 3. So 2x is equal to 3, divide by 2. X is equal to 3 halves. And wasn't that part of my domain restriction, 3 halves? My other one, horizontal asymptote. What's my horizontal asymptote? Just 1 half? I need an equation. Y equals 1 half. Because I've got the same denominator, I've got the same exponent. I take the ratio of the coefficients, 1 over 2. Make sure you give it to me as a 1. Okay, so we got this part done. Now we can pretty much sketch. I have a horizontal asymptote. I have a vertical asymptote. Oh, I lost my color. I have a vertical asymptote at 3/2. I have a horizontal asymptote. Okay, now I can sketch. And notice this guy, well maybe let me find my intercepts first, so I know exactly where these pieces are going. My x-intercept, where do I find my x-intercept? Zeros of what? -1, so where did you look for that? Like, oh, and you said zeros of the, because you went to your numerator, right? Zeros of your numerator. You're absolutely right, I just want to make sure everybody knows zeros of the numerator. So I'm going to cross over here. That's going to help me graph. My y-intercept. My y-intercept, go back to the original. It's probably the easiest. You don't have to deal with your factor. You can go to this one, but I like to go to the original. That comes out, I'm left with 1 over what? -3. Okay, so I'm crossing over here. Real tiny over here. So doesn't that help like your sketch a little bit? So my sketch is coming above that line, crossing down, guiding by this. And this one's going to guide like this. Okay? So far, so good. Let's do your point of discontinuity. We put this over to the side for a minute. Point of discontinuity. X plus 1 equals 0. So where x is -1. So where x is -1, let's find the y. If I plug a -1 in here, I get a 0 over something. Something I don't really care. 2, -1. So what's my intercept? -1, 0. That's my point of discontinuity. But uh-oh, that point I can't use. I said that was a 0. So do I really have a 0 for this? For the x, I have no 0. No zeros. No x-intercept. I didn't know that till I went back and looked at my point of discontinuity, right? But now I can't use that guy. So really, I don't have an x-intercept. He actually jumped right over the x-axis. It's a removable point.
How did you get the horizontal?
The horizontal asymptote says, is that right?
Okay.
Check those. Go back to the original. It's easiest to look at the original. Yes.
Now this is like probably a stupid question,
That is.
but for some reason my brain isn't really working and it's not factoring like the big denominator. Like the 2x,
Okay.
whatever. I don't know why I'm not doing it.
So can we get back? Well, I'll get back to your factor.
Okay.
Okay. So let's just go. I'm going to get back to it. I just want to follow the flow of this.
Yeah.
Okay. So now you can find your range. Wait, do we have any maximums and minimums here? No max, no min. So let's find our range. Our range starts here. We're looking at your y values. Comes all the way up. It says, whoops. Can I use that 0 here? No. I'm going to jump over the 0. Up, I got an asymptote here. So which one can I not use? I can't use 1/2. I'm going to jump over 1/2, and then, yeah, you can use the rest. Find your range after you found your max, your mins, and your point of discontinuities, and all your asymptotes. Okay? So we found all these guys. We had none of those. Concavities. This guy over here is considered a concave down. Concave down, I'm also decreasing there. If it actually increasing, decreasing. But I have a little problem. As I concave down, I got to jump over this point. So from negative infinity to what x value? Negative 1. Then I'm going to jump over the negative 1, and I'm going to hit this wall right here. Where? What value of x? 3 halves, or 1.5. Okay. This guy's going to concave up. He doesn't seem to have a problem. So where am I concaving up? 3 halves to where? Infinity. Good. 3 halves to infinity. Good? Are we good with this? This is important that you get this. Okay? Let's take a look at these factors. Okay, you have a couple of ways you could do this. Because these factors are prime, well not prime, but they only have one set, they're actually both prime. They're both prime, they only have one set of factors. 2 is the only even number that's prime. You could start like this, 1x, 2x. And the 1 and the 3 have to go here somewhere. The last thing we do is multiply, and we get a negative. So one's going to be a positive, one's going to be a negative. If you want, you could try this. You need your factors to take the difference, because they're both different, right? To be a 1. So would I want to multiply my 2 by my 3? What is 2 times 3? 6. The other one's going to be 1. I could do this. Watch. Put them in. These are my middle terms. I'm going to get 6x, and I'm going to get 1x. Does that difference give me 1x? Nope. So I can just switch them. 1x and 3. Now I'm going to get a 2x and a 3x. Does that difference give me 1x? And which one do I want? I want this to be negative. I want whoever multiplies by him to get the negative sign, because I want the difference to be negative. That's one way, because these were just both prime numbers. They only had one set of factors. But you can always use your A times C method. Yeah. Your A times C says this. Take the 2 outside. 2 times negative 3. What does this give you? Negative 6. Can you find me factors of negative 6 that the difference is negative 1? Negative 3 plus 2. Good. So plus x is next to this. And just rewrite this. 2x squared minus 3x plus 2x minus 3. Now, group the first guy. Is there anything I could take out of that? An x. So I'm left with what? 2x minus 3. Now, out of this guy, it is the same exact thing. I'll just take out a 1. Technically, I could take out a 1. So there's my factors. 2x minus 3, and what's this other guy that's left? X plus 1. That works all the time as well. That'll work all the time when you do that.